Welcome to the second in the series of WebToDo screencasts. This screencast is entitled Application Firewalling for REST Web Service. In this screencast we're going to first of all introduce REST, WebToDo and the XML HTTP request object. We're going to see a sample and look at code and how it works. Then we're going to see how the WebToDo XML Gateway adds threat detection, SSL, certificate authentication and rate limiting to WebToDo websites. One way to look at WebToDo is to look at what came before. In Web 1.0, users filled out forms, pressed submit. This made a post or a get to a web server. There was a wait, and then a new web page was returned to the client. They would then see the new web page with the form results being shown to them. Web 2.0 is more dynamic. Websites feel more like applications. Flickr, MySpace and others have code that runs on the web page, connects back to services and returns dynamic data to the website user. The example we're going to look at is a stock lookup service here. The user types in information here, Microsoft stock symbol. They just press on the text there and they see the stock result come back. There's no wait while another page is coming. There's no wait to see the page loading. It's instant and very responsive. If we look at the source, we see how this works. It uses the XML HTTP request object there, sometimes called the XHR object. This runs in JavaScript. It connects back to a web service. Here you can see the web service it's calling back to is Apache Access Web Service. The XML HTTP request object calls back to this with JavaScript and it gets back XML. The XML contains a stock value. That's AJAX, asynchronous JavaScript and XML. In this case, using the XML HTTP request object with JavaScript to connect back to the service and then to pull the data back and then to use the information from the stock quote to pass as a parameter to the web service on the server side. The REST service that we're connecting to is one of the examples that comes with Apache Access. This is freely available. You can install it yourself. REST web services now are described in WSDL as of sub 1.2, and here you can see the request we're sending is to a service called getPrice. We can use this directly in the browser, type in getPrice, then our parameter, which is the stock symbol. We press that, we see the XML that comes back. This is the XML that's been pulled dynamically back to the browser by the JavaScript which we just saw using the XML HTTP request object. So you can see how Web 2.0 works. Now what we're going to do is put in place an XML gateway in front of the backend web services. This is going to provide SSL, authentication, threat scanning and rate limiting for those backend web services. Here's the WebToDo Policy Studio, which is where we define the policies that are going to be used by the XML gateway. We're defining a path for that backend web service. We're saying that any traffic that comes into that web service from the browser is mapped onto this stock quote policy. Firstly, it does the routing to send the request back to Apache Access. So it connects back to the appropriate server and port. We're going to add in a validate query string filter here. It's going to look at the stock symbol that's been passed back from the XML HTTP request object. We're going to just, to start off with, make sure that it's alphabetic. What we're going to do then is check for the presence of certain attacks that could be present. A SQL attack is one that we're going to look at, and another which we're going to look at is an XPath attack. We're going to check if that's present in the data that's coming back. What we're going to do is change the name here to say validate the stock lookup symbol. We're going to include that now within the policy. Once we've dragged it into the palette, you can see that we use a green line to link it in so it happens before the routing happens. We set that as a start. First thing we're going to do is ensure that the stock quote symbol that's been passed back from the XML HTTP request object is valid. If it's not valid, we're going to construct a message that goes back to the client. We're going to simply return back the word forbidden. This is what comes back if the message is not alphabetic, if it includes any of the 2 attacks that we've configured to look for. So here we're setting the forbidden message, and then we reflect that back to the client. So that gets reflected back. Now in the browser, we see that if an attacker types in the SQL injection attack and then they click on the text to look up the stock value, the forbidden message is what gets sent back. This is generated by the XML Gateway when it sees the SQL injection attack. Next, what we're going to do is set up SSL. SSL requires a certificate, and we can make a certificate right within the Policy Studio. Fordel's XML Gateways give you the option of using a certificate that comes from a CA, such as VeriSign, or from your own corporate CA, or you can create, as in the case of this demo, a certificate right in the XML Gateway itself. We're going to do that. We're going to create a certificate and just self-sign it for the purposes of this demo. That means that it's useful for the mechanics of setting up SSL, but not for trust, because anybody can create a self-signed certificate. That gets created. If we go and look at the private key, what we can see is that you have the option of storing that on a HSM. HSM is a hardware module that ships with Fordel's XML Gateway appliances. We're going to give this an alias name so we can remember the certificate when we see it in the list of certificates. We press OK, that gets added. You can see our new REST certificate is right at the bottom there. We're going to use that to set up SSL on the gateway. We will go up to the gateway and we choose to add a new interface to it. It's a HTTPS interface for SSL. We have to choose various different parameters, including the certificate and the port. The port which we're going to choose is 8081, which is a port we know to be open on this particular gateway. We also are going to choose the certificate. We choose the certificate which we've just created. It's the REST SSL certificate. We choose that, we press OK, and that will then create the SSL interface on the XML Gateway, and then the XML Gateway will now be listening on the SSL channel. In order to see SSL in action, we go back to the browser, we type in our REST service, we go in using the machine name in this case, which has to be equal to the common name within the certificate, and we attempt to access the service now over SSL. We choose the port 8081 which we set up. Now we're going over SSL. We can prove that SSL is happening by clicking on the padlock within Firefox, and we see information about this certificate. It's not trusted because it's a self-signed certificate, but you can see that high-grade encryption AES-256 is being used for the connection now from the code within the browser back to the backend web service. So that means our AJAX requests now are going over SSL. So we have SSL in place for the encryption. Of course, that's just one level of security. We also use the content filtering to make sure that the data that's going over that encrypted connection is also valid and does not contain any threats. What we're going to do next is add further functionality in SSL by enabling mutual authentication. What this means is that clients accessing our REST web service now must present a certificate. We're going to say that the certificate issuer for the trusted connection to the SSL service is our REST certificate that we just created. So that means that we're now going to create a client certificate rule within the policy to enforce SSL authentication. This means that anybody connecting now to our REST web service must present the client certificate. We add that at the top. That's the first thing we're checking, if the user has presented a client certificate. If not, then they will be blocked from accessing the web service. You can see if you mouse over any of those, you see the inputs and outputs. Now if we go back to our web service and we attempt to connect without going over SSL, what will happen if we refresh the page is that we're blocked with access denied. We're not allowed to connect to the service. What we're going to do now is create a client certificate which we're going to use for authentication at the browser. Again, we create the common name by which the client will be known. We're going to call this REST client. We don't have to put in all of the attributes here. We're going to put in an organization name as well. We'll see that later when we look at the certificate being used for client authentication. When we choose to sign the certificate, we're actually going to sign it with the public and private keys that we used before. So that then means that the certificate we created before becomes the issuer certificate. This maps with how we've set up our demo, and in a real life situation normally you'd be using a third-party certificate authority such as VeriSign or a corporate CA as being the trusted issuer of certificates. A REST client now is shown within the list of other certificates. We're now going to try to connect to the service over SSL. Our policy says that you must authenticate. We're asked here to choose the certificate to authenticate. This is the REST client certificate that we just made. We choose that certificate, and then that will mean that we're allowed to connect. Notice that's the REST client. And now we can connect. We are now allowed back into the web service, and we can use it. We type in the value, we get it the value come back. We put in the SQL injection, and we see forbidden come back as well. Again, if we click on the Firefox settings, we can see information about SSL being used and the authentication in place there. Next, what we're going to do is add rate throttling to our REST web service. This is often used in the WebToDo area, whereby if you're exposing a service to the internet, you don't want people to use it in an unreasonable manner if they're using too many lookups against a search service or product lookup service, for example. We're going to say if there's more than 10 requests to this REST service in a minute, then we're going to block the messages. We also choose to cache the information, so if there's multiple XML gateways, they can all share that information. So if 5 requests go to one gateway, 5 requests go to another gateway, then we still know that there have been 10 requests in all, and we can block based on that. We're also doing the rate throttling depending on the identity of the client which we've identified using a certificate. If we block a client, we're going to then set the fault handler to be a policy shortcut to sending back HTTP 403 forbidden. If we repeatedly click on the text here, we see access denied comes back. We have gone over the allowable number of connections. Looking back at our diagram, you can see the XML Gateway is now providing authentication, SSL, threat scanning, and rate limiting for the backend REST web service. This is application firewalling for a REST web service. We'll look back at the agenda to recap on the various different items we've seen. We've seen what WebToDo is, how the XML HTTP request object is used, and we've seen the XML Gateway from Vordel in action. If you'd like an evaluation copy of the XML Gateway, if you'd like to find out more, look at Vordel's website or contact info@vordel.com.